Welcome to everyone. Today we are going to discuss about the topic of introduction to voltage. So this topic comes under the branch of electrical engineering, and in electrical engineering there are various branches. So theory of electrical circuits. So this topic comes under electrical circuit theory. Okay, fine. So today we are going to discuss about the voltage in detail. Okay, so before going to discuss about the voltage in detail, so this voltage comes under active elements. Okay, so there are active elements and passive elements. Active elements means voltage sources and current sources, like uh, and passive elements are resistor, inductor, and capacitor. So there are many classifications. So today we wanted to discuss the active element called to be voltage source, and then followingly we can discuss current sources and everything. Okay, so first of all, what is voltage? So in this first point, voltage is the pressure from an electrical circuit's power source that pushes charged electrons through a conducting loop, enabling them to provide a electrical source, electrical energy. Okay, so voltage is considered to be the pressure. So pressure of the fluid, we can say, pressure of the blood in the human body, pressure of the fluid in a liquid medium, liquid flow, water flow. Like, okay, so we can consider, or we can compare this voltage to the pressure of the liquid system or pressure of the human blood flow system, right? So but it should form a closed loop, closed circuit. In order to have a current path in a circuit, the path should be the closed one, right? As we might have studied earlier, right? So in brief, voltage is totally equivalent to pressure. Okay, so it's like one backward pressure which will bring forth the electrons from one point to another point. Okay, so there will be 2 points from one point to another point. The voltage is the major thing that will enable the electrons or charges to flow from one part to another part, or one junction to another junction. So without the voltage, the charges can never be moved. Okay, will be stationary, right? If the charges are going to be stationary, what will happen? There won't be the flow of current, then there won't be electricity, we cannot, right? So basically there is an essential of a voltage in the circuit, then only it will boost, or it will bring forth the electrons to move from one place to another place. So it was invented by Alessandro Volta in 1745 to 1827 is living time in the world. Okay, so in electricity, voltage was known as electromotive force. We will discuss this electromotive force, EMF, in detail in the coming slides, right? So EMF and potential, electric potential and voltage, all are going to be the same concept, right? Okay, so it is represented by the symbol E. Okay, E for EMF, electromotive force. Okay, so this voltage will be used in Ohm's law also. Ohm's law we will discuss in another one presentation. Okay, so next we are going to see about the basics of voltage. What is voltage? Voltage is basically pressure. That is a basic concept. Okay, so it will enable the charges to move from one place to another place, or one point to another point. In electrical engineering, we used to say that junction number one, junction number two. So when we analyze the Kirchhoff's voltage law and current law for mesh analysis method for finding the current and voltage, so we will take the junctions, right? One junction, another junctions. So that means particularly resistor is connected in two points, right? Or any sources can be connected to points. So the one, point number two, right? So this is what we wanted to calculate the voltage at this point only. What is the voltage? Voltage should be connected. Voltmeter should be connected in parallel with that, right? So voltmeter, for a unit of voltage is volt. It is voltmeter is used to measure the voltage, right? So let us see one by one, right? So a definition is a measure of the difference in electric potential between 2 points. So if you are if you are connecting 10-volt battery with a resistance of 1 ohm, like what would be the voltage across the resistor? So we can discuss these topics in detail. So before that, what I want to tell you is what is voltage. right? Voltage between 2 points, that means 1 ohm resistance is connected, that 1 ohm resistance point number 1 and point number 2, so there is a variation, right? So that is the potential difference or electric potential difference, right? That is the voltage. Okay, 1.1 voltage, another 1 point, there is a variation, right? Okay, that is the variation is electric potential, right? So to calculate the voltage, we can use two formulas. One is from the Ohm's law, another one is from the power equation, right? So Ohm's law is V is directly proportional to I, so V is equal to IR, and power law equation P is equal to VI is the product of voltage and current. Okay, so it is expressed by the symbol V. Okay, so EMF, volts, everything is same, expressed by the letter V, first letter of the voltage. Unit of voltage is volts, so first letter of volt is V, right? What is the use of voltage? Okay, so look at this electrical circuit. This is the electrical circuit. So here resistance is connected, or resistance is connected, and this is the voltage source, right? Voltage source. This is the active element, this is the passive elements. Passive elements are resistor, inductor, and capacitor. Active elements are power sources like voltage source as well as current source. Okay, fine. So here voltage, so when the voltage is applied to this electric circuit, you know that voltage is the combination of cells, right? So here the battery is connected, the battery is powering the voltage V to this entire circuit. In order to have the current flow in an electrical circuit, this circuit should be the closed one, right? As we have studied, closed circuit is essential, right? Fine, so current flow is there. What is the current flow? How does the current flow develop in this electrical circuit? Because of the voltage. So indirectly, at the back of this current flow, there is a work done, right? Work done in moving the charges from this place to, look at this place to this place, and here to here. So movement of charges are to be done with the help of the voltage. The voltage only will give the force to possibly move the electrons from one point to another point, right? So this is the essentiality of voltage. So without the voltage, there is no movement of charges. So if there is no movement of charges, no current flow is there. So we cannot estimate the current flow. We cannot have the current, right? So that is what the main thing over the usage of voltage. So voltage is very much essential in an electrical circuit to power voltage, right? Voltage can be considered as the pressure that forces the charged electrons. You know about the charged electrons, right? Who might have studied in PN junction diode and everything, right? So electrons to flow in an electrical circuit. Okay, so as an electrical circuit, not to in order to have the current flow, and there is an essential thing that electrons flow is mandatory, right? Without the electrons flow, that means electrons is otherwise called as charges. So without the movement of charges, there is no current. We might have studied already that the flow of charges are to be said to be current, right? Okay, so without the movement of the charges, if the charges are stationary, found to be stationary, there won't be an electricity, there won't be a current flow, right? So in this case, voltage is very much essential. Okay, fine. So the flow of electrons is the electrical current that flows in it. The flow of electrons. This is the very, very basic thing. Flow of electrons is the electrical current. Okay, fine. Let us move on to the next slide. Potential difference. So voltage or voltage difference, potential difference both the same, but the difference between two junctions. Look at the previous slide. So look at this. K1 K1 voltage will be there, K1 voltage will be there. There is a variation. This variation will be will be referred with the help of voltmeter. If you want to measure the voltage with this across this resistance, you can connect one voltmeter here parallelly. Okay, we can connect one voltmeter here parallelly. With the help of multimeter also you can measure this. Okay, fine. So let us look at the potential difference at two specific points in an electrical circuit. Okay, so look at this. Look at this circuit A and B. See this here. 1.5 volt battery is connected to power the lamp. To power the lamp, right? So here in this point P and C, there is a lamp connected in it, right? So this lamp is connected and the circuit is complete. That means it is connected fully without any break, right? So it is it is the closed circuit, right? Okay, fine. So what I want to tell you is from A point to A, that means junction A to B, there is a constant voltage. There won't be the voltage variation. Okay, fine. Now from B to C there is a voltage difference, because at this point B and at this point C there is a restriction, because this lamp will offer some resistance, because just tungsten element, right? This tungsten element will offer some some sort of resistance to this voltage, so this voltage will be varied, right? So from point B to C there is a voltage difference. From C to B the same voltage will be delivered out, right? So likewise, so this starts from plus point and ends in negative point. So plus point is the higher voltage terminal and negative point is the lower voltage terminal. Okay, so likewise, see, look at this diagram, totally 1.5 volt, that has to be the potential difference. So from point A to B, there won't be any difference. The same 1.5 voltage is flowing, right? From point B to C, what will happen? There is a difference, sudden voltage drop, right? So then C to D, there is a no difference. Okay, so now it has reached. Look at this diagram. 6-volt battery is connected to power for two lamps, right? So from A to B, there is no difference, 6 voltage. And from B to C, one lamp is connected, right? So there is a voltage variation. From C to D, the same voltage is continued. From D to E, another one lamp which offers resistance. So voltage is getting deteriorated. And from F to E, zero potential. Okay, fine. So this is the difference. That means if you connect any passive elements like resistor, inductor, capacitor, so there is a voltage drop in it, right? So that will be measured with the help of voltmeter, right? Okay, fine. So voltage drop. So another one study is there, potential drop, potential rise is there. Okay, so here I can tell you here from A to B, no thing. So P to C, potential drop, right? So here no rise is there, drop, because here the path of resistance is given, right? Okay, fine. So this diagram represents the 12 volt battery is connected across the lamp here. From A point is the positive and negative point. Okay, so here high potential and here low potential. Okay, so here only the charges are started to flow from this point to this point. Okay, so when it reaches the lower potential, the voltage will be considerably lower. Okay, fine. Let us move on to the next slide. Next slide shows the comparison between the potential difference, voltage, EMF. Both are same. EMF is a separate study that we can analyze in like generator. So generator EMF production, EMF equation, that will be discussed later on. Okay, fine. Potential difference we have studied, and voltage is the voltage, and voltage is the pressure, and EMF. Okay, in a battery, a series of chemical reaction occur in which electrons are transferred from one terminal to another terminal. There is a potential difference, right? So here coals and here electrons, coals and electrons, right? So here the coals, that means charges, right? So the flow of charges. So due to the flow of charges from one point to another point, there is a potential difference, right? So that we have studied in the previous slide, right? So here also the same thing. The maximum potential difference a power source can have is the EMF, maximum potential difference. That is the power source. 1.5 volt is the maximum potential difference, right? So other than that, potential drop will be there based upon the connections and path of resistance given into the circuit. Okay, so both are same, but the representation is somewhat different. Voltage V, capital V, potential difference del V. Del is a small change of voltage, right? And E. Okay, so E, it's not F alone, E. Okay, E is EMF. Okay, fine. What is the unit of voltage? Okay, unit of voltage is volts, right? Okay, so the letter V, or we can represent with the help of volts. The SI unit of international system of unit, right, is the volt, such that 1 volt equal to 1 joule per coulomb. Okay, so coulomb is one coulomb only, 1 coulomb of charges. To move the 1 coulomb of charge, how many joules of energy is needed? Okay, motion. Okay, mechanical energy, motion, the small mechanical movement, right? Okay, so for a voltage of 12 voltage is connected means what is the thing? 1 coulomb of charge will gain 12 joules of potential energy. To gain 12 joules of potential energy, 1 coulomb, that is a 1 volt. For a battery connected, uh, you know, uh, connected as 12 volt battery. Okay, fine. So in order to gain the 12 joules of potential energy, the 12 volt is connected in the electrical circuit. Okay, that is the voltage. Fine. Okay, so let me highlight the voltage with the help of this diagrammatic representations. Most of the people is imagining the voltage to the fluid. Okay, fluid flow. So fluid also will flow with a pressure. Likewise, current also will flow with the help of pressure called to be the voltage. Right? Voltage is pressure. Right? Fine. So voltage is the work required per unit charge to move those charges, right? So here is the voltage. This voltage will consider this fluid as charge, right? So this voltage is pressuring the piston and the charge is getting, moved from one place to another place, right? Likewise, charges are moved with the help of voltage. So this is a nice pictorial representation representing the voltage, right? Fine. So look at the battery. This is the battery. Battery only offering the voltage, and so this will voltage will force the charges to move from one place to another place, right? High potential to lower potential, and in between many parameters may be connected. We can connect, right? So this voltage is considered to be the pressure, and it can be imaginated to the fluid under pressure. Okay, so when the fluid is given a pressure, what will happen? There is a flow of liquid, right? Likewise, when the voltage is given into the electrical circuit, current starts to flow because charges are getting accumulated. That means it starts from one place to another place. It started moving after the voltage is given or after the battery is turned on. Okay, fine. So voltage is the workhorse of all circuits. So this is the essential of all thoughts because voltage, carries a lot of work, right? Without the voltage, there won't be the flow of charges and there won't be the electricity. Okay, fine. So let me give the simple circuit and animated view of this. The picture illustrates a single cell packet and carrying the 1.5 volt battery is connected. And with the help of this battery, one lamp is connected and one lamp is glowing, right? So see this charges are from plus point to minus point. That means plus is the high potential and negative point is the lower potential. So that now how the charges are, you know, so how the charges are moved from one place to another place from high potential to low potential. Okay, fine. And then it emits electrical energy here and right, fine. So without this boost, electrons would be happy to remain stationary. If the electrons are happy to be stationary, there won't be electricity, right? So this is a animated pictorial representation representing the voltage in a simple circuit. Are you able to understand or you got it? Okay, fine. Thank you very much for watching this video, and if you are interested in this video, you can subscribe and click the bell icon button, and you can share it to the electrical engineering students as well as diploma students about the voltage. Okay, let us rock. Thank you.